Okay, so this week, so first of all, welcome to the uh, Python users group meeting. This week we are going to cover the Voluptuous Python data validation library. I'll go ahead and post a link to the documentation I'm going to be working off of for this demonstration in the chat. So there you go. So Voluptuous is provides a simple and straightforward way of describing a schema that you can use to then pass Python data objects into it, and it will validate. And if you so desire, can optionally do data coercion for you. So this is especially useful if you've got data coming in via, say, JSON or YAML, and you want to validate the data structure before you start working with it. So let's look at a simple example here. And if my text is too small to read, somebody call it out, and I'll make it bigger real quick. But usually, it's already pretty large, so I'm not going to worry about it. So from Voluptuous, import schema. Okay, and a schema object we create by passing in a Python object that it then uses to validate the things that we pass in to it. So we can do schema equals, and then we're going to make a schema object. And it's pretty straightforward. You just pass it a Python object that's, so in this case, we're going to pass it a dictionary, and we're going to pass it a set of key value pairs. And the keys are the keys that we expect, and the values are the types that we expect them to be. Now, there are some, and then we'll talk about the limitations of this through example here. So I'm going to do just a simple example. We're going to do Q, and its type is going to be a string. And then we'll do, let's see, per page. So the example that they're giving here is actually describing the API. It's describing the API for Twitter. And so we're going to use a very simple example here that's actually incomplete. And we'll talk about the limitations as we go forward. So then we do a page and then an int. Okay, so this describes our schema, and then we use the schema by passing Python objects into it. So something simple would be, and then what it does is it returns the object. If we don't do any type coercion to the object by, like, say, converting strings to integers or anything like that, then it will return the object as is that we passed in. So let's see, result equals schema, and we're going to call our schema object, and then we are going to pass in the object that we want to validate. So let's just pass in Q, and we will give it a string, something like that. And then just for completeness, we will print the result. Okay. And so if we run this guy, that will run it. It prints out the object that we passed in. So then what happens if we pass it in something that doesn't pass our schema? So if we do something like this, we get an unhandled exception. Or we get an exception, and the exception describes what was wrong with the object that we passed in. So Voluptuous has a multiple invalid exception that describes what was wrong, and it uses it fails fast. So at the first thing that it finds wrong, it fails and it returns. Now, Brandon, I don't know if is there a way that you can get it to find all of the problems before it returns? I didn't see anything in the documentation that described that.
Yeah, I don't recall seeing anything like that, and I've never tried to do that.
Okay, that was just something that popped into my head as I was reading through it. So okay, so
yeah,
we'll
that could be helpful. But
Yeah, it could be helpful if you want to do like a more complete list of errors, but I didn't see anything in the documentation, so I'm going to assume that you can't do that um, for now. If we run across something that where it is possible later, then maybe I'll bring it up in a future meeting. But I didn't see anything in the reading, and if anybody was going to know off the top of their head, it'd be Brandon. So, okay, because he's used it way more than I have. Okay, so you'll notice that it also didn't fail because we were missing keys. So it doesn't care about keys. This simple schema doesn't actually specify that the keys are required. So let's try another test here. Let's specify a key that does not exist in our schema and see what happens. Okay. Extra keys not allowed foo. So our schema is defined so that only the keys that we have defined in our schema are allowed. So there's a keyword argument that you can specify when you, I forget if it's when you define the schema or when you use it, where you can allow for extra keys. We will get to that. It's later on in the documentation. I saw it. I can't remember which one it was, so we'll get to it. So we are not allowed to use keys that do not exist in our schema. So we're going to go back to our original queue. Now, there's some limitations. There's some other limitations that in our schema. The first one is that the Twitter API puts limits on these values in our schema. So it's not just enough to say per page it needs to be an integer, but there's upper and lower bounds on per page and our page value. Also, queue and per page are required values. So let's update this schema to enhance it to make it more in line with what is actually required by Twitter as specified by the Twitter API. So we're going to import required all length and range. So the first thing we're going to do is we're going to use required to specify that these keys are required. So required is a callable a class object. We instantiate an instance of it. Now our queue key is required. Also, we want to specify that not only is this a string, but it needs to be a string of at least length 1. So we can use the length. We can use all combined with length to specify that it's a string and that it's also has a length of minimum 1. So all is basically allows you to create a union of requirements on a value. So we're going to say all. So the first requirement is that it needs to be a string, and the second requirement is that it needs to be a length. And we're going to specify a length minimum of 1. So now our queue key is required. It has to be a string like it was before. Now we have to have something in there. Okay, so now we're going to make per page required. And we're going to set its default value to 5. Default equals 5. And if I understand this correctly, if it's not included, it won't complain, but it will just put in a value of 5 for you. So again, we're going to use all. It needs to be an integer. And then the second requirement is that it falls within the range of minimum 1 and a maximum of 20. So this will force us, this will cause it to complain if our values don't fall within that minimum and maximum range. And of course, we're still enforcing the fact that it needs to be an integer. Page is optional, so we are not going to put it in a required object. But it does have a range where we can't give it a negative number. So we're going to, again, all integer and then range min 0, like that. Okay. So now if we give it an empty string and run it, it's going to complain because the length of value must be at least 1 for a dictionary value of Q. So we'll go ahead and put something in there. And we'll go ahead and run that. Okay. Now, as I mentioned before, per page is required, but we've also given it a default value. So if it wasn't specified, it will be injected with a default value of 5, which of course falls within our requirements. So then we can go ahead and specify our per page. And if we give it a value that's out of range, so if we say it's 0, then of course it will complain. All right. So in practice, what you want to do is catch the multiple invalid error when you're processing this data, and then report an error back to the user that supplied the data. All right. Let's see. So since Q is still required, if we pass it an empty dictionary, now it will complain about that. So required key not provided, data Q. And of course, it still must be a string. So if we were to pass it something other than a string, it would complain in a way similar to the way it did before. Now, this does not, the way this is set up, that this does not do any sort of coercion. So if we specify Q, and we say it's value 1, of course, this will work. Oh, finish with it. Let's see. Oh, expected, it's expected a string. Oops. Ha, ha, ha. Okay. And if we specify the per page, that needs to be a value between 1 and 20. So 5. So let's make it something different. So 10. And if we run that, that works properly. This does not try and coerce it to the appropriate type for us. So this will complain. And that will not work for us the way we want. Okay. Example. Okay. Let's go ahead and open up another example to work off of here. In this case, now we're going to talk about how schemas deal with literals. So one of the things that a schema can do is you can just create a schema that says we expect this value, full stop. So the way we do that is like this schema, and then we give it the actual value that the schema is expecting. So if we call our schema with a 1, let's see, let's do this again. That it will just work. If we try and pass any other value into our schema, it will complain. Not a valid value. So, and all it's doing is checking for that literal. So if we change this to a string and then try to run it, it'll say it's not a valid value. And it will only succeed if we pass it the literal that it is expecting, like that. So that's the simplest thing that you can do with a schema. Then the next thing is you can change this. So then when you build on that, we say, okay, well, now we're going to switch this to a type. So we can do something like this. Then it will accept any value that falls within that type. So if you want to narrow it down to a type, you just give it the type. If you want to give it a dictionary with a particular form, you give it a dictionary. So here's one that I actually didn't play with very much, but I just am now noticing it in the documentation, and I think it's cool. We can also do URLs. So if we import URL and then pass that into our schema, then the schema will only accept valid URLs. So we do http://w3.org. So that will work as expected. If we pass it something that is not a valid URL, which I'm curious to see, yep, that's not a valid URL, it returns an error as expected. All right. And then we'll get into useful information that you can get out of the exception that's raised a little bit later. Now, lists in a schema are treated as a set of valid values. So let's do. So if we wanted to do, if we wanted to say anything in this, any one of these set of values is valid, we would give it a list. So we can do something, I mean, we can literally do something like this. Okay. And if we try and run this, of course, it will complain because let's see. That's actually not what I was expecting it to do. Oh, that's right. We need to pass it a list. That's right. So if we pass it, so lists in a schema are treated as a set of valid values, and then each element in the schema list is compared to the value of the input data. So it wants, so when you give it, when you're using the schema, it's, in this case, it's looking for values that, it's looking for a list of values and all of those. So basically, it's validating that the list that you give it is a subset of the list that's in the schema. So in this case, it says not a valid value at data 0. But if I change this to, say, A, then it will pass. So if we want to, if we wanted to, say, just work with any list at all, this is not valid. So this will fail because it's not, A is not considered a valid value because it's not in the list defined in our schema. If we want to say use any list, then we would do something like this. So we would say, oh, like that. And that tells it that we are looking for an object of this type. So then that passes. We can also do sets and frozen sets. Let's see. So we can do, so if we're looking for a set like this, or let's see, let's give it a value 42. Okay. Then we're expecting a set with the value 42 in it. And if we pass it an empty set, it complains because it was expecting a particular set. So let's see. So if we wanted to, let's see. So if we wanted to specify a set that can contain anything, much like the list you do set. Oh, that's not a set. Ha! I was wondering why that was failing. That's not a dictionary. That's not a set. That's a dictionary. Let's try that. There we go. It's like, man, that did not make sense. Yeah, so because this is a subset of what's in the schema, it works. If we wanted to just do, so if we specified another set and that set had like 21 or something like that in it, it would not work because it's an invalid value. If we wanted to do any arbitrary set, of course, we could specify it with the set type, and then it'll work. Okay. Are there any questions? Okay. So now we're going to get into writing our own validation functions. And this is handy if you want to do things like type coercion and stuff like that. So we'll go over here to example 4. Okay. And we're going to add in the invalid object here. Invalid, so if you want to write your own validation function, invalid is the thing that you need to raise if there is something wrong with the object that gets returned. Now, you can just return a value error, and Voluptuous will try and do the appropriate thing with the value error. And this is handy because if you want to do some sort of type coercion, a lot of like built-ins in Python will raise a value error, and so Voluptuous will just do the right thing. So let's write a simple schema that is expecting a date in a particular format. So let's do date time, import date time, and then we'll do def date, and then we'll specify a format. So the format is going to be whatever we want to. In this case, I'm going to copy and paste this so I get it right here. Because I always, so this is just a format string. And then what we need to do is give it a function. We need, Voluptuous wants a function that it can use to call on the object when it's doing the validation. So we're creating a date function that returns another function. So this way we can specify our format. If we just wanted to specify a function that just takes the object directly and does something useful for it, we could do that as well. So let's see. So we're going to do return lambda v, and then we're going to do date time from string from time. Let's see, no, it's 2 times, so it's going to be this guy right here. And then we're going to do the argument that was passed in and the format that we're using. Now, if we wanted to not make the format something that we could modify, then we would do something like def date, and then pass in v, and then return that right there. So, and the distinction is important because one is configurable and the other is not, and the way that you end up using them is different. So we'll because one of them is returning a function, the other one is the function that you're using. And so the way that you end up using them with Voluptuous is different. So we will comment this guy out for now. Let's see that. There we go. Okay. And so how do we use this? Why is it complaining? Oh, not enough blank lines. All right. So we're going to create a schema based on our validation method here. Schema equals schema. And then we want it to validate with our date. So we're going to call date like this. So we're calling the method so that it will return this lambda function. So we're basically giving the schema a function to use for validation. If we had done the second example, instead of doing what we did here, where we are calling it. So this method up here allows us to specify a different format if we're so inclined. If we do it like here, our format is fixed, and so then we would just pass in our date function as is. So that's the difference. So we're going to get rid of this first one, or the second one, because we don't need it. So now we're going to pass in a value to into our schema. So we're going to say results, or result equals schema, and then we'll just give it a date here, like that, and print result. Okay, so if we run this guy, it not only does it run the validation, but it also coerces it into the new type, because whatever our validator returns, that is what ends up in the resulting object. So it's not enough to merely run the validator, or to run the schema on the data structure that you want to validate. You need to use the results from the schema itself. So we're doing two things. We're validating it, and we are coercing it into the appropriate type. All right. So if we pass in something that's incorrect, so this will fail. And if we run this, we say it automatically, if the validator raises a value error, which is what's happening here. If you pass in an incorrectly formatted string into strip time, it raises a value error, and then Voluptuous does the right thing and turns it into a multiple invalid error and raises that. So that's a simple example of coercion and validation at the same time. Okay. What was that? Yeah, 303. Okay. So let's create another example file here and do something a little bit more sophisticated. So we can, following the example that we used for date, to where we can make our coercion method, or we can make our validator configurable, we're going to define a function called coerce. And this is going to it's going to coerce the value. And this is actually a nice general example that they have here. This is straight out of the documentation, but this is actually kind of handy. We're going to write a validator that doesn't care what the incoming type is, but will attempt to coerce it into whatever type you specify. And if it's not valid, it will raise an exception. And if it is valid, it'll just work, and it'll be coerced into the new type. So I am just literally going to copy and paste this and explain what's going on here. Okay. And I need to schema equals schema, and then we're going to specify coerce. Okay, so we won't pass a date. We'll just pass something like this. Okay, so now we have another validator that, again, is configurable. And one of the things that we have to specify is the type. So I'm going to specify an integer for the type. And then we have this an optional message argument. So what this does is this returns a function that takes in the value that's supposed to be validated, and attempts to run that, the type that was provided to our course method on the value that was passed in. So this allows you to do things like you could specify a class type, or in this case, for this simple example, I'm specifying an integer type, and it will attempt to run the value with that type, and then it'll return the new value. If it fails with a value error, now we're going to provide a better message. So if we don't want to rely on Voluptuous's value error handling, we can actually raise the invalid exception type, and then we can specify a message that is appropriate. So if we don't supply a message, then it just uses a default message. Or we can specify our own type, or our own message that's more appropriate to the failure case. All right. So if we run this, it will print out the integer. Come on. There we go. 1, 2, 3. Because it worked as expected. And so we can use this to, we can do any sort of validation that we want to on the data type that's sophisticated. It also opens up the possibility of doing cross-value validation, which we'll explore here a little bit towards the end. Okay, so I had mentioned before that if we were going to add extra keys to a dictionary, it would cause a failure case. So now we're going to talk about how to allow that. So there's a value in Voluptuous called extra, or allow extra, excuse me. Allow extra. And if we define allow extra when we, that's what it is, when we create our schema, so it's this, an additional argument to our schema constructor, extra equals allow extra. This will allow us to specify additional values that are not actually defined in the schema. So if we do something like, foo equals 42. So if we run this, let's see, per page expected int. Oh yeah, I need to fix this now. So if we change this back to 10 and run it, now it'll work. And so allow extra just tells it to, in the case of dictionary handling, to ignore any extra values that come through. All right. So the other option is that we can, instead of allow extra, we can do remove extra, which causes it to not complain if anything extra comes through, is passed into our schema, but it will just strip it out. Okay. So by default, as we saw earlier, not all keys are required unless you specify the required constructor. So there's also an optional keyword called required equals true. And what that does is that implies that all of the keys are required. So this required is no longer necessary. So the equivalent is this. Now, because I have a default, I need to specify a default. I have to leave that in. But then if we want the same behavior as we had before, we can use optional. And I accidentally deleted all. There we go. And so optional is basically the inverse of required. And so if you have everything needs to be required except for like one or two options, then you can set required equals to true and then use optional to specify the things that are still optional. So it's whichever is the least amount of work to specify, like so. Okay. Let's see. We can also, let's create another example for this because it's different enough. We can also specify, we can also have schemas that are nested. And I'm just going to copy and paste this because it's easier. Where if we want a schema to refer to itself, like a recursive schema, you can use the self keyword. And so what we've done here is our schema is more is a reference to self, and then our value is an integer. So we can have this a schema within a schema within a schema. So so in this case, both of these are still considered optional. So value equals 42. If like value 42 was or if more self was required, then the schema could never resolve because your recursion would never end. So you have to make your recursive reference in your schema has to be optional. And so now in our when we evaluate this object, we look at the more keyword, and the more keyword is basically an instance of another instance of the schema itself. So that's how we do the recursion. So let's see. Throw away the equality check there. All right. So this is how you can do some sort of nested recursing schema. If we run this guy, it passes. Okay, so we can also take an existing schema and we can extend it. So sometimes it's useful to have a base schema that you can build off of. So for instance, we define our base schema here, person, which is just a name that has to be a string. And so that becomes our base schema. And then we can create a new schema from the original schema by using the extend argument. And so that allows us to add keyword value pairs to our existing schema in this case. And so we can, oh, that's interesting. I didn't know you could list that off. So now this person with age is a new schema. The original schema has been unmodified, but now the new schema also includes the age keyword. And we can also come in and say person with age. We can do introspection on we can look at this the schema itself, which is the schema object that was passed in the first place. And in this case, it's going to be the dictionary that we built up. And then we just call the keys method and get the all of the keys from our combined schema. All right. I guess before I go on, are there any other questions? Okay. So in one of our examples here, let's see if I can find it. Okay. Oh, that's right. This is actually a different example. Okay. So we'll do one more example, and then I think we'll call it a meeting. So if you want to support, actually, I've got two more examples. So if you want to support none, you would use the any keyword. So if a value in a your schema can either be like, say, an integer or a none, or if you want to support multiple types, you use the any object. So the way that you do this would be something like this. Well, that's interesting. Voltron office hours just signed into the call. It must be Jeremy.
No, it's actually Craig.
Oh, hi, Craig.
I'm aliasing. Never mind.
Okay. So in this case, now our schema will accept either an integer or none. And we can extend this as far as we want. So we can also make it accept a string. So now we could do schema is none, schema is 5. That's how you do, any is basically your OR operator for your schema. All right. And the last example I'm going to give, so there is error reporting is covered in great detail in here, but I think we'll skip over that because this is the last example that I find very interesting, and this is the multi-field validation. So what this allows us to do is do validation based on multiple fields at the same time. And again, I'm just going to copy and paste this out of the documentation and then explain what it's doing and how it works. And of course, create the appropriate imports. Import schema, invalid, and all. All right. Okay. All right. So what's going on here is that we are creating a schema where all of the values must match. So we're using the all keyword here to say that we need to check for one thing, and then we need to check for the other thing, and both the checks have to pass. So our object that we are expecting is a dictionary with 2 values in it. Now, you'll notice that I don't have this set up as required, but it actually doesn't matter in this case. So we're expecting a dictionary with two keys, password and password again. They both have to be strings. So that's our first validation. And then the second validation is, now that we know that it's a dictionary, so that's the first thing. We already know that it's a dictionary, and we already know what the keys are. Now, this is actually something I want to test here really quick to see what happens, because I think if we try and pass this in, if we are missing keywords, it's going to have a keyword error here on the second step. So I want to check and see how Voluptuous handles this, because I'm curious. But once the first check passes, then it's the second check is to call our validation function. And so now we're going to basically compare the values of the 2 keys. Password and password again must be equal. If they're not, we're going to raise an invalid exception. Passwords must match. And then we're going to return password. And then we're going to return the original passwords dictionary unmodified. So I'm going to comment this out so it passes. And as you can see in our first example, it validates correctly. In our second example, so we'll go ahead and comment out that and uncomment this one. If we run the second example, it's going to fail because our passwords do not match. let's see. So let's go comment that out. So I want to try a third example just to see what it does. Oh, darn it. There we go. Okay. And what I will do is I will take out the second keyword argument, because I believe the way this works is that it will pass the first part because I haven't specified required here, but I'm not sure. So let's just try it and see what happens. Oops. Okay. Okay, so it is failing with a key error. And so the first part of the validation is not quite working the way we'd expect. So let's try this and see if we can fix it. Let's go required. And let's see if we can get it to fail in a more appropriate way. Oh, what are you doing? There we go. All right. Let's run this and see what it does. Required keyword not provided. Okay, so this is actually a better example, because the example in the documentation doesn't include the required field, so we don't actually know by the time we get to our validator that both of these keywords exist, and so this is actually a more correct version of the example. So yeah, this will in addition to validating that both of the that it only has the keywords that are the keys that we care about. Those keys are now required, and so now we won't get to the second function call unless we know that this passwords is going to have the keys that we care about, or that we need in order to do our validation anyway. So okay, yeah, that's all I've got. Are there any questions? Brandon, is there anything you'd like to add?
Yeah, so before I found Voluptuous, I was using another library that's actually called Schema.
Mm-hmm.
And it was kind of similar, but a little bit clunkier to use.
Yeah.
Especially with writing your own validations, you actually had to subclass their base class, and it was, or I guess it didn't need to, you didn't need a subclass or base class, but you had to kind of duck type your class to match what they're expecting.
I see.
And then it also didn't do as good a job of printing where the validation failed. So just to throw that out there are other libraries that do this, but right now Voluptuous is the best I've found.
Cool. So I mentioned in the email going out that I was going to talk about this particular library, is that it would be useful for Voltron application developers. And let me expound on that a little bit. So a common consideration for application writers is writing a configuration handler. And currently, there isn't, because the configuration store in Voltron puts no, other than it needs to be able to be JSON serializable. There are no requirements for what can go into the config store, and so because the config store is agnostic to what the agents need, you can put configurations in the config store before you ever install the agent. So there's no way for the agent to tell the platform what format those configurations should take. And so then it becomes up to the agent to do basically schema validation to configurations that come in before they're processed. And it's currently common practice to really not do any validation. You usually attempt to do an update, and then you check for, and then you update the default dictionary. And if they've done something weird, like put a list for a configuration in, then that update call fails. And then the values that that are pointed to. So you end up doing a bunch of stuff where you have like a try except clause with a bunch of value error checks and stuff like that. And so as I was going through the documentation today to in preparation for this presentation, I realized that this would be very, very handy for Voltron users. Now, Voluptuous does support Python 2.7, 3.6, and 3.7, and probably older versions of 3, but officially it's 2.7, 3.6, and 3.7. And for a Voltron, for somebody writing a Voltron application, it would be useful to be able to just define a schema in Voluptuous and then take whatever comes in to their configuration handler and run it through the validation, and then possibly then combine it with the then you would go ahead and combine it with the default configuration and then maybe validate it again, or something like that, where you can have some assurance, and then you don't have to worry about doing the type conversion yourself. You just have one spot that says, okay, we've defined it. We do a try except. If that fails, we know we can't use this configuration, and then we have some information about what's wrong with it, because then we can report the error message in the exception in the log, so that the user knows what happened. And then you don't have to worry about putting try except handlers all over the place. You just have one call that you make against the configuration data structure to validate it before you start messing with it. So for one of our internal applications, I'm considering doing that going forward. But I thought I'd throw that out there. I figure Craig and the Voltron community would find that useful.
Yeah, I was actually thinking about that as you were discussing it.
Yeah, it's like a natural fit, isn't it?
Yeah, it really is.
So
this is really cool.
Yeah. So I hope that's helpful. I don't have anything else. If there aren't any questions, we'll call it a meeting. Thank you all for coming.
Thanks, Kyle.
Yep,
hey,
thanks.
Kyle, just one question. Where are you posting these?
I haven't posted them yet. Okay. There is
this one interests me. So
yeah, well, yeah, and you got here right at the last second. There is a GitHub repository. So if you want to install it, it's just so can you?
I assume you can get it from pip, but
yeah, you just pip install Voluptuous. There is the Git, and then you just go to the GitHub repository. Can you see in the Zoom chat the link that I posted to the GitHub? Because that's what
I got in here too late.
well, let me just post it again, so then you can see it. It's yeah, there you go. So that's where the good documentation is. There is official documentation, but it's just basically the auto-generated from the doc string stuff. The real meat of the documentation is in the README on their GitHub page.
Okay.
Okay. All right. Thanks everybody for coming. I will catch you all later.
Bye-bye.